Thank you for joining us for the Utah Energy Code and Building Science Lunch and Learn, presented by Dominion Energy and Rocky Mountain Power. My name is Becky Robbins, and on behalf of the Governor's Office of Energy Development, I'd like to welcome you to our free Lunch and Learn. These are held the second Thursday of every month, and you can attend either here in person, where we provide lunch and one Doppel credit, or you can attend our live stream. As many of you know in the audience, that's what we have today, so just keep that in mind as you're going in and out of the room. These trainings would not be possible without our partners like Salt Lake Community College. Their energy management program, which is led by Alyssa Kay, who is sitting here and you'll hear from in just a moment. Just want to say, just a reminder, we do have a new website, so if you're ever looking for our materials, you can find our quick reference guides and past presentations, including the videos, all of it on utahenergycode.com. And if you ever want to live stream these, you just go there to our live stream page, and it will link you to the YouTube channel that we broadcast these. So make sure to check that out. We currently are a little behind on getting stuff on the website for our next trainings, but I want you to know we've got one scheduled for Valentine's Day, because we love our energy officials in Utah. And our lunch and learn that day will be on who's responsible for code compliance. And this will have both a residential and a commercial focus, so make sure to keep an eye on that. And again, that'll be Thursday, the second Thursday of every month, so February 14th. We're planning more. We've got them in the works, so just keep an eye on our website. Make sure if you're not on our email list that you add it. I'll have a option to do that on our survey, or if you're online, feel free to do that on our website. Couple announcements, because we are recording today. If you do have a question, Brent is going to need to repeat it so that people online can hear it. So just give him a second after you ask him a question so he can do that. Also want to just let you know that the presentation materials for those online, you should have seen it on our website, so you can get those there, or if you're here in person, we have copies. Those will eventually be posted to the website. For those online, we'll take a 10-minute break at lunch. Everybody will get a chance to grab a lunch, which we'll have up here at the tables. There'll be different options for you. And we'll come on at about 12:10. So those online will just see our hold slide. Other than that, those here, please silence your phones. If you need to take a call, please go out in the hall. And like I said, these trainings would not be possible without the utilities. This is the majority of the funding that comes to these, or that are responsible for putting on these trainings. And so in the audience, we have a representative from both of the business programs who, after the lunch, will talk for just a few minutes about what are the incentives and rebates, both available from Rocky Mountain Power and Dominion Energy. So now I'll turn the time over to Alyssa Kay, the program manager for SLIC's Energy Management Program.
So on behalf of the Energy Institute at Salt Lake Community College, thank you for being here today. We're proud to support the Utah Energy Code training series and provide energy efficiency education for building professionals such as yourselves. The Energy Institute at Salt Lake Community College is an award-winning program that provides clean energy training for advancement in your career in the building, HVAC, and clean energy industries. All of our instructors are professionals currently working in the field, and our curriculum is developed by a program advisory committee made up of highly qualified industry professionals. So here's what we currently have to offer in spring semester starting in March. The Energy Management AAS degree teaches residential, commercial, and industrial energy efficiency, including HVAC, lighting, controls, and financial analysis of energy efficiency improvements. The degree is offered in an accelerated format and can be completed in as little as 18 months with online and evening classes for your convenience. Our solar certificate is offered twice a year, and it takes only 2 courses to complete a certificate in solar sales and 1 additional course to complete a certificate in solar installation. The majority of coursework is online, and students meet on Saturdays for hands-on training in our new solar training yard at the West Point campus near the airport. This certificate prepares students to take the NABCEP exams. Our residential building energy course is taught by a HERS rater and provides training in energy efficient building envelopes and systems for residences. This is a 10-week course that meets on Monday evenings starting in March. The HVAC Energy Analysis Certificate begins in May, and this is a great option for HVAC professionals and builders who'd like to learn more about how to optimize systems for high performance. Additionally, we offer certificates in energy efficient lighting, energy accounting for business, energy modeling, and building automation and controls. We're easy to find. Our website is slcc.edu/energy. And if you have any questions, I'll be here today and you can ask me as well. So thank you so much for being here. And I'll let Becky take it from here. Thanks.
All right, now I'll turn the time over to Brent Ursenbach. He's a energy and mechanical code specialist at WC3. He recently retired from being a building inspector for Salt Lake County. His previous experience includes 33 years as an HVAC contractor, and for 5 years he worked as a teacher here for the energy management course. He currently serves as the past president of the Rocky Mountain Gas Association, and he serves on a number of energy code and mechanical advisory committees. Brent has presented numerous seminars, and we are lucky to have him as our local resource. So I'll turn the time now over to Brent.
Thanks, Becky. It's good to be here. Lots of familiar faces. I'm even learning some of your names or know some of your names, but sorry, I'm never going to have them all because I constantly teaching a new group of people, and it's hard to keep them all straight. Maybe part of it's my age, I don't know. But anyway, it's good to see you. I want everybody to know that I really want you to ask questions, to participate. If you ask a question, as Becky said, I'm going to have to repeat it. So let's try not to have a 5-minute question that I need to condense back down to 10 seconds to repeat back. Try to be concise so I can repeat it to those that are watching online. But your questions are welcome, and also your questions and comments, suggestions are welcome by email or text, and if it's critical, you can try to call me. But those of you that try to call me know that much of the day I can't answer my phone. I'm doing something that prevents me from answering the phone. So text or email typically work better, and I probably will get back to you quicker if you email me a question, and I'll answer it, at night or something like that. We are going to talk today about commercial mechanical provisions, and quite honestly, we could do this class and take 3 days just covering the commercial mechanical provisions in the IECC. So it's going to be brief and touch on the key issues that we address in the energy code on mechanical systems. So don't consider this a concise, complete encompassing of all of those things. We will be doing some all-day classes where we'll get into a little more depth. So this is really for everybody so that you understand, we do have Economizer requirements. We do have, various requirements scattered through the mechanical code, so you have a general outline of that code. Becky mentioned, our sponsors on this, and I really do want to repeat and reiterate that we could not do this without the support of the utilities, both Rocky Mountain Power and Dominion Energy, and of course, the Office of Energy Development, who pays for my time to do these classes and to answer your questions. I like to answer your questions and stuff, but I also have a life, so I can't spend 20 and 30 hours a week just giving my time up. Why do we care about the IECC? Why do we care about building energy efficiency? Excuse me, 10, 15 years ago, as energy efficiency became a bigger interest and a greater focus, and in fact IECC and those older guys, those of you who have been in code enforcement for a while will remember that the 2003 energy code was very difficult to follow. We had like 18 climate zones. We had to do all these calculations all the time. We didn't, ComCheck was not as friendly as it is now. And in the 2006 energy code, it was simplified, and the book went from this thick down to about this thick. Well, it has since grown a little bit, but it was simplified to where it makes it a little easier to understand if you're not an engineer. And with that, you know, it's coincident with the change in our country. We're trying to conserve a little bit of energy. I don't believe energy conservation kind of has a bad connotation to it, that you think, well, if I'm going to conserve energy, I have to set my thermostat where I'm uncomfortable, and I have to do things that I don't like, that I'm not comfortable. And I don't think that's the path we want to go. I think the path we want to go is build a good building that's efficient, that's comfortable, that has good air quality, and all these things, and doesn't use a lot of energy. And we know from experience and from what we're looking at and what we're reading about that people are building buildings that virtually use very little energy and also experience a higher level of comfort. So that's really the way I look at it. You know, Bill and others in here that work in the comfort industry know that the typical individual today demands a much higher level of comfort than they did back in 1972 when I first became involved in the HVAC industry. When I first started working in the industry, we didn't put air conditioning in almost any house when it was new construction. Even homes in Pepperwood and all these places, they'd say, well, we'll see what we need to do when summer comes around. Do we build a house now without air conditioning? I don't think so. Very rarely do we see a house built without air conditioning. The public is demanding a higher level of comfort, so we need to build a better building, whether it's where we work or where we live, and it has become more technical, so we need to understand building science a little bit better. So code buildings are more comfortable, they're cost effective to operate, they ensure energy, economic, and environmental benefits. Now, I'm not going to jump on the table and holler that everybody needs to build a net zero building, because I really don't think that's a practical thought right now. That is not my current goal. A couple of things. I'm going to have a hard time giving up my natural gas barbecue, my gas range, my tankless water heater. But my tankless water heater is the most efficient tankless water heater I can buy, and the cleanest burning tankless water heater I can buy. And so that's kind of the direction that I think we need to go. Well, something happened with that slide, didn't it? The IECC, for those of you that don't have a copy of this, it's divided into two sections. The front 2/3 is commercial energy, and the back third, roughly, is residential energy. And so we're going to talk about the front 2/3. And the format is like any other code book. We have chapter 1 is the administrative sections, 2 the definitions, 3 general requirements, and then for the energy code, chapter 4 in both sections is, where we get into the real code requirements. Chapter 5 is new, existing buildings. Previously on an existing building, we had to kind of go through the whole code and pick out little bits and pieces on what happens with an existing building. They've all been gathered together in one section or one chapter, and then chapter 6 is the reference standards. So chapter 5 in both residential and commercial makes it a little bit easier to follow. And as we're talking commercial buildings, you need to be aware that you need to go to the existing building code too to accurately enforce the code there or understand the code. In chapter 1, we have a definition or a list of requirements that we need to include on plans, and so the design professionals need to be aware of this list. The plans examiners need to be aware of this list, and if you're the builder, you also need to be aware of this list. And what I've done This is the list that's listed in section C103. I've put blue text on everything that's related to mechanical systems. And you might say insulation materials, fenestration, U-factor, solar heat gain coefficients, how are those tied with mechanical? Well, of course, how you build the envelope has a direct impact on the mechanical system, the design of the mechanical system in those buildings. And then these items here are all directly mechanical. And then air sealing details also relates to mechanical, because I don't think I ever did a mechanical job that I didn't make some kind of penetration to outside or through a roof. And because we do that, we need to be aware of what's happening with the building envelope and how we need to seal the building envelope. So it's quite obvious that mechanical is an integral part of that building, and we can't simply say, well, I'm just worrying about the mechanical. I don't care about the windows. I don't care about the weather barriers or the air barriers. Everybody needs to understand the code in general. Okay, my soapbox issue of anything else when I do a plan review is I get a comm check, I get a load calculation, I have a set of plans, and the R values and U factors and solar heat gain coefficients and all the data is different. I have specifications, and we have inconsistencies between all these different documents. I look at a comm check and it says the windows are going to be 0.40 U factor windows, but I go to the specifications and it says they're going to be 0.47. I go to the plans and it doesn't say anything. How do we ensure that that building gets built correctly? How does the mechanical engineer that does the load calculation accurately do a load for that building if he doesn't have the correct information? Several years ago, it was very common that everybody was relying on center of glass for the U factors on windows. When you have an aluminum frame window, the center of glass U factor is going to be half of what the overall assembly is when you account for the aluminum frames. So you have a large building with thousands and thousands of square feet of glass, and it's modeled with a U factor that is half of what's the actual. What's going to happen when the building's finished and the energy consumption is almost twice of what was anticipated? It's important that these numbers are accurate. It's not a set of numbers that we put on a set of plans so that we can get a permit. It's a set of numbers that makes the building work. And so we need to make sure that these are accurate. Whichever side of the building construction process you're involved in, it's so critical that on the plans and the specifications, the energy compliance documents, and any of the HVAC design calculations, that we have consistency across all these documents. We have buildings across the country, not just here in Utah, that literally were modeled as having glass with a U factor of 0.26. I have no way to get an aluminum framed window with a 0.26 U factor. It can't happen with current technology. Maybe if you put 3 or 4, 5 panes of glass and a really good aluminum frame, you might get there, but that's not accurate. That's not what's happening. So we just need to make sure they're right. And I'm not saying you have to have the very best window in the world. We just need to make sure we're using the right data. And it really affects our mechanical systems. Okay, I just got a text message yesterday on this. The IECC allows you to use ASHRAE 90.1. You don't have to use the IECC. You can use ASHRAE 90.1 to show compliance. However, if you choose to use ASHRAE, you need to use ASHRAE for the envelope, for the mechanical, and for the lighting. You can't pick and choose and say, well, the lighting and power requirements in ASHRAE are a little more restrictive, so I want to do that IECC, but I like ASHRAE for envelope or I like ASHRAE for mechanical. You pick one and you stick with it. I get all the time where I do a review and we have, both of them. A ComCheck that's envelope for the mechanical, and maybe the other two are ASHRAE. And I send it back. You have to use the same one. Well, which one do you want? That's not the code official's decision. That's the decision for the design team. Decide which path you want to use and use that path. So today we are not focusing on ASHRAE. We're going to focus on the IECC. So we have selected the IECC. And here's the two paths basically that you have. We have a prescriptive path where we basically follow the tables. We can do a little bit of trading off in here with ComCheck, or we do the performance approach where we do an energy model for the building and show that our building will use equal or less amount of energy compared to a standard reference design building that's code compliant. So we can do either path. We're mostly going to focus on this path. That's generally what we see. If you choose the performance path, you will notice that it says do all of these things. You do meet the air leakage requirements. You meet applicable mechanical requirements and water heating and lighting. And then the building has to perform 15% or have energy use 85% of that standard reference design building. So what this says is follow the code and then do something to make sure the building's 15% better. Well, the prescriptive path kind of does a similar thing. It says follow all these requirements in the code and then pick one of these 6 enhanced energy conservation methods. Pick higher efficiency HVAC, or reduced lighting, enhanced lighting controls, on-site renewable energy, high-efficiency service water heating, dedicated outdoor air systems. So 3 of these are directly related to mechanical. And in fact, Don and I were just talking about code changes. We need to, for the 21 code, I'm going to submit something where we put or some other method that shows a large savings or a substantial savings. And the one that comes to mind for me is, how many mechanical contractors? Mechanical engineers? Very good. Contractors, code officials. Okay. Our larger high-end buildings, what are we seeing in the cooling systems? We're seeing evac cooling. Very effective, very efficient. We're seeing, multiple stages, indirect and direct evap cooling that saves huge amounts of money, more than 15%. We have buildings, new high-end buildings that chillers don't even turn on until in July because they're able to do all their cooling with evap cooling processes. So if someone comes to me and says, well, we're doing our building like that, I want to use that as an alternate method in place of one of these, I would happily accept that. But I would like to put something in the code that recognizes that there are those types of things in parts of the country that will qualify for that. Okay, mechanical issues that we have to look at. Air leakage. There's a couple of things that we really need to be considered. We need to consider if we're involved on the mechanical side. And that's our rooms containing fuel burning appliances, our air intakes, exhaust openings, stairways, and shafts. So as mechanical contractors, as mechanical engineers, those of us involved on the mechanical side, we do have dampers on air that were drawn from outside. We have these penetrations that we make that we need to seal. We have air leakage on those dampers. We have rooms in our building that have gas burning appliances that have combustion air ducts ran to them that we need to be aware of. And so one of the first things in this, the Utah chapter put this into the code. I don't know why it's doing that, do you? The slide's flickering? Read fast. Anyway, my computer wasn't doing it. I'll just summarize this slide real quick. If you have a room with open combustion gas appliances in it, with an open combustion air duct ran to it, you need to isolate that room from the rest of the building. Why? Because we have a great big opening outside, right? And we're consuming air out of that room. So we need to isolate that so it is not impacting the rest of the building. Let's see if it goes away on the new slide. Also, as we work on mechanical systems, we have penetrations through the envelope. We have penetrations on a home or a commercial building where we have ductwork in attics, and then we're penetrating the ceiling. We need to seal those openings. In fact, the Commercial Energy Code gives us 3 options to qualify the envelope, and this is kind of mechanically related, but it's more envelope related. There's also a requirement or an option to blower door test the building. So we can, if we're looking at commercial buildings, they can blower door test the building. It's a little bit different test pressure. It's 75 pascals instead of 50, and it's a CFM per square foot, not an air changes per hour number. That's option 1 for the envelope. Number 2 is we use materials that have a low air permeability, and we seal all the joints. Or number 3 is our building has been tested. If you have a CMU block building, it has been tested that if you put a coat of block filler and a coat of paint or 2 coats of paint, that it'll be tight enough to meet the requirements in the energy code. I bring this into a mechanical discussion simply because if they are testing or any other one of these things, we need to, as mechanical people, make sure we are doing our part to seal the envelope where we penetrate it. So the 3 additional efficiency packages that they have a choice to choose from: more efficient HVAC, dedicated outdoor air systems, or more efficient service water heating. Those are the mechanical ones. Let's talk a little bit about those. High efficiency HVAC, basically we have tables in the IECC that say, and there's like 8 pages of them, that say, for instance, if you're less than 5 tons, you have to have this Seer rating. If you're more than 5 tons, you have to have a minimum this EER rating. There's a efficiency rating for PTAC, motel, hotel type units.
Sorry, I want to go back 1 slide.
Okay, go ahead, Troy.
And that's regarding the testing, and this would just be a plea to building officials that if they're going to ask builders to get their buildings blower door tested, let them know at the beginning and not the end. It happens to me all the time that someone calls me up and like, I just found out I need to get this tested. They didn't do any air sealing during the construction process, and now it's building's done, and we're trying to figure out how to make it tight.
Thank you for bringing that up. I get a thumbs up from Steve here too. The comment is, if you are involved in a building that is going to be tested, make sure you let your testing people know up front as the building construction starts so that they can help you through the construction process, ensuring the envelope is built to where it will pass the test. I think what your experience is, you get called, the building's completely enclosed and drywalled and everything, and they want you to test it, and it's really hard for you to fix all the leaks in it.
Really hard to fix finished buildings, yes.
Please.
Just to comment on that, we stick a little sticker that says right on there, this has to meet this and such rating, and it has to be tested at the final. A lot of times we write it the 4-way, Yet we still get to the final and the contractor says, I didn't know. That's really hard. And now with the change going to 3.5 on residential, that's one of those things that if general contractors, as much as we tell them, if they don't look at those notes, they don't read their plans, it's going to catch them.
The comment is that jurisdictions are actually putting stickers, stamping the plans to say this building has to be tested by final. If you're involved in the process, you need to pay attention to those. You do need to read the plans. The biggest complaint we have as inspectors is we go out and we want to see the plans to do an inspection. We open the plans, Kathy's smiling, and there's very specific things on the plans that haven't been done. It's so important to read the plans. Steve?
That usually the stamp that I see says it must pass the 2015 Utah IECC code. They have no idea what IECC code is at the builder's level. And that's a reason that all of a sudden it's a surprise that they have no idea all this stuff that's involved in that code.
Okay, the comment is sometimes the stamp says it must comply with the Utah 2015 for a residential or the 2015 IECC. That's a great point, and it ties in with what's required on the plans. I've done jobs, and I bet you Bill has done jobs, HVAC jobs, that had really crappy plans that I wished I would have walked away from before the job started, because the lack of information on the plans means the job is going to go to hell on you. I mean, it's really the fact. In fact, there's some jobs that I wish I would have written them a check for $10,000 and said, go get someone else to do the job, and I would have been money ahead from doing that job that was so poorly defined on the plans that you just lost a bunch of money on this plan. So it's so important that we have a good, complete set of plans and we follow it.
Related to the building testing, I'm just curious, has anybody had any experience with aero barriers?
The question is, anybody had any experience with aero barrier? And we observed it for one of our trainings last month. Right after that training, an aero barrier is a system, and I don't know if it's done commercially at this point, but it's done residentially, where they literally raise the pressure of the house and spray a mist that seals the leaks. And right after we went on that training and saw one of those, I received a phone call from one of the inspectors at Salt Lake County where I used to work, and he says, I got this aero barrier report. And it says it started at 5 air changes per hour, and when they were finished, it was 1 point something air changes per hour in 2 hours of sealing the house up Immigration Canyon. And that's my experience.
Yeah.
I've had discussions with the representative writing the new legislation that they're going to be discussing come the end of the month, and the HBA, and they're interested in it. And it's one of those innovative things that allows us to seal the buildings. Anyway, really, a good set of plans, read the plans. As code officials, I mean, maybe your stamp needs to say more than you have to comply with the energy code. We all need to, as a team, really be involved if we're really going to successfully do this. You HVAC people, you need to be thinking more, not have that tunnel vision. We need to be thinking of our system as part of that building system. Good comments and questions. So commercially, if they choose to use high efficiency equipment, then they have to exceed those table requirements by 10%. And if they have multiple systems or multiple performance requirements, they need to exceed those by 10%. So it's really centered on a 10% improvement. Whether it's variable refrigerant flow, or if you have equipment that's not listed in the tables, then you can't, it's limited to 10% of the total building capacity. The other option is dedicated outdoor air systems. You cannot take a large commercial building and say, well, I'm going to do the bathroom on the top level with an ERV. That's a dedicated outdoor air system. I qualify and I get credit for it. This only applies when you have large ventilation requirements and you're providing virtually 100% outdoor air to the let me read it. Be equipped with an independent ventilation system designed to provide not less than the minimum 100% outdoor air required by the IMC. So what that's saying is we have a ventilation system that's providing all of the ventilations required by the IMC to the building. Correct? I mean, the IMC gives us very specific instructions on how much ventilation air we have. If you choose this option, you have to make sure that all of that ventilation air that's provided to the building meets this set of requirements that provides efficient ventilation. So we do total energy recovery, we have some supply air temperature controls and reset controls, and some temperature limits. We could go in and spend an hour on that one, but it requires addressing all the ventilation air in the building if you want to use that option. And then finally, the reduced energy use in our service water heating. You can't use this one for an office building that all you have are lavatories for washing hands. It has to be a high water usage occupancy or use. You know, boarding houses, hospitals, restaurants, laundries, places that you're going to see a lot of hot water usage. And then you need to show that you're reducing your energy use by, again, 10% in those types of buildings. And still related with that service water heating, you can do some things like energy recovery, heat recovery from your chillers to be making hot water. Those are some of your options, or even solar. So basically recovering some of the waste heat that you're going to be throwing away anyway and using that to heat hot water. Go back one. Wow. Well, that slide was basically a mechanical introductory slide. We'll skip that one. Someone, if you have an idea as we get through that.
We'll look at it halfway through.
Okay. The IECC used to have simple systems and complex systems that we had separate requirements for them. Those have gone away. We don't have the simple system even discussed in the IECC anymore. So our Economizer requirements apply to everything. So don't be worrying about that. So the mandatory provisions, and when I asked for these, you know what I get, plan reviewers. No one's ever asked for this before, right? These provisions apply to all mechanical systems. Load calculations. I ask on my commercial projects for summary pages of the load calculations. What am I looking for? I'm simply looking to see what? The R values and the U factors they used in the calculation. I'm not looking for a stack of printout this high from, what is it, Train Tray 700 or whatever. I don't want to see that. I want to see that we used the correct thermal performance factors when we did our load calculations. Equipment and system sizing, a complete equipment schedule. Performance requirements. When we have an equipment schedule, it'd be really nice if they listed the unit that they are speccing and the efficiency of the unit in the equipment schedule. The system controls, we need to have in the plans, in the specifications, a sequence of operation, some information on the controls. Are the controls compliant with what's required by the code? If we have boilers, do we have outdoor reset and setback controls? Have they addressed ventilation? If they're doing energy recovery ventilation, have they included that in the design? Kitchen exhaust systems, duct and plenum insulation and sealing. You know, this kind of ties back with the stamp. A stamp that says insulate the duct and water lines per the code means what? That it's just going to get insulated however they choose to insulate it. They're not going to be going back and looking, well, what does the code say? We need to ensure that's on the plans or in the specs. Commissioning, we'll talk a little bit more about that one. When you hit a certain level, it's not an option anymore. You now have to commission your buildings. And we'll talk about that one a little bit more. Heating outside the building, refrigeration equipment has to meet performance requirements. That's new in the 15 code. If you have a grocery store with lots of refrigerated cases and stuff like that, there are requirements now for those refrigeration units. For walk-in coolers and freezers, refrigerated warehouses, there's also requirements now. So the load calculations. I want to caution you, some of you have been doing a pretty good job on your residential load calculations. You're looking through them, you're getting accurate information on them, and you're even asking the HVAC contractors in here to justify the sizing of their equipment. When we get to commercial buildings, I've probably had a dozen phone calls on this, we need to understand that there are a number of commercial occupancies and uses that have huge ventilation requirements, where we have huge amounts of fresh air coming into the building and being exhausted out of the building. And guess what? Our value of the insulation in the walls and the roof and stuff really is almost inconsequential depending when you consider what they're doing in the building. Bill's nodding his head. You know, I was asked to get involved on one for ARUP. 100%, you know, it's laboratory stuff, 100% outside air. They're not recirculating any air because of the testing and the, you know, and all the disease and everything that they're testing for in that building. You know, understand that the load calculation on that type of building is something that you probably ought to just have a discussion with the mechanical engineer and ask him, not worrying about the envelope, but worrying about what? Are we efficient in our ventilation? Are we able to modulate it depending on the use of the building? There's other things that we need to look at rather than just the envelope, because the envelope means almost nothing in that particular application. If you have questions on that, feel free to get in touch with me. So I've added the comment here, if you want to circle that so you're aware of it. High internal loads, large ventilation exhaust requirements may drastically change the impact of the envelope on the total load. In fact, it might make it almost meaningless. So those tables, this is number 2 of 10 tables. So this one's an air-cooled, less than 65,000 BTUs, either split or single package. You know, currently it should be 14 SEER. Were you aware of that? The residential code just says follow the federal standard. If you're doing a commercial building, a little strip mall or something, and they're putting residential type 4 and 5 ton condensing units or rooftop units on it, 13 SEER doesn't meet the code. Troy.
So any multifamily residential building 4 stories or taller falls under that, doesn't it? 14 SEER then?
I never even thought of that, but yes, it would.
Okay.
It could apply, yeah, it applies to a residential building too. I'd have to look in the footnotes and see if there's an exception for a residential building. Bill?
Just a comment that I don't know if building officials are aware of, but you know how condensing units typically have an energy guide sticker on. It'll tell you what the SEER rating of the equipment is. there's been a pretty major change in that, in the way they are doing that now. It used to be that they typically rated it at the nominal efficiency. Now that sticker will rate the lowest efficiency. So you could have a sticker on a condensing unit, for example, that says it's 14 SEER, and it actually might be a 16 SEER unit, depending on the other components of the system. So that energy guide sticker has now been changed to use the worst case scenario rather than the actual scenario that might be installed. So it kind of throws a little bit of a wrench. You could, it could have been submitted as 16 SEER, everything approved that way, and then you get out there on the final inspection and see the energy guide that says it's 14.5 SEER. And as a building official, you would think that they're not meeting this standard. And you need more documentation to prove what the actual components are.
That's a great point, Bill, and I'm gonna maybe build on that a little bit. What Bill said is, it used to be that you bought a 13 SEER condensing unit, and it may or may not be 13 SEER. It could go less, it could go more. It was kind of how the manufacturer picked it. Now, if it says it's 13 SEER, that is the lowest that unit produces with any one of the combinations. What you need to be aware of is the difference between SEER rating and EER is the SEER includes the indoor fan. It takes into account what we're doing inside. So why does it go away when we get in bigger stuff? Because we buy the condenser from here, we build up the air handler. We don't have that nice, pretty set of documents from the manufacturer that says you put this coil with this unit with a TXV, you're going to get this SEER rating. So if you are using these smaller systems, less than 65,000 BTUs that are rated with SEER rating, they could install what by model number looks like a 14 SEER condensing unit, but if they coupled that with a variable speed furnace and the right coil inside, it might be 16.5 SEER. That accurate, Bill?
That's right.
So
And you get that with the AHRI report.
you get that with the AHRI report. That's correct. You need to get that report that shows what you get with all those components. So taking that another way, if they are submitting and saying, we're passing our mechanical because we're using 15 or 16 SEER, then you need to make sure that you get that report and ensure that they use those correct components that gives you that performance. Yeah, that's something that as a contractor, I really bothered me because I would go through the effort of matching up the best furnace, the most expensive coil and everything, and tell them, we're going to give you 16.5 SEER, and someone else comes out and says, well, we're going to give you 16 SEER, and they were giving them 13 because they weren't doing that. Please.
I'm just curious if 14 SEER as of January 2016, is that for both new construction and replacing old equipment? Is that the new standard?
Yeah, that would be, yep. And I hadn't even thought about it, Steve, on multifamily, or Troy, whichever one brought it up. And that's why these tables are important that we look at them. But give me a chance to look at the footnotes and see if that applies to Rs 2s, 3s, and 4s. You know, my comment here is very, very important. In commercial projects, components from multiple manufacturers are often combined to create a complete system. System controls. Every zone needs to have a control, a thermostat. Larger systems might have central building management systems or central controls for that building, but each system has to have a thermostat, and it has to have some setback and setup capability. That's required across all pieces of equipment. I'm not crazy about setback thermostats on residential homes or using them for anything other than I make my house cooler at night so I sleep better. So in this summertime, I turn my air conditioner down. But in commercial buildings where we go unoccupied for long periods of time, they're very useful, and there's a very big benefit there. For those of you familiar with heat pumps, I checked on this because someone who tried to eliminate this requirement in the code for years and years and years. It was optional when you installed an air-to-air heat pump that you put on an outdoor thermostat, which basically prevented the auxiliary strip heat from kicking in if it was warm enough outside to handle the load. That's required by the code. It's not an option. If you're installing an air-to-air heat pump and you have electric strip heat for your backup or your auxiliary heat, you have to have outdoor thermostats. Those of you familiar with heat pumps and how they work understand that resistance heat costs you like 3 times as much or more than what your heat pump will produce for you. And so we don't want to use that strip heat until outdoor conditions demand it, simply because we're too cold. If you have auto changeover, you have to have at least a 5-degree dead band. Okay, these are the, let's just go through this real quick. This is what you need to be able to do with your setback thermostat or your central BMS systems. Automatic time clock or programmable system, with an exception if you have zones that operate continually, or if you have small zones that have a readily accessible shutoff switch. And a small zone is 6,800 BTUs. That's pretty small. So if you have an operation like, well, you guys in the city, I don't know, is your UPS building finished yet? That's a 24-hour operation. The building's never going to go unoccupied. It's running all the time. What value is there in all this setback and off stuff when the warehouse space is maintained at 55 degrees all the time? Because they're always unloading and loading and everything else. So why do we go to this elaborate system? There's no need to. There's other hospitals. Lots of areas in that hospital are occupied all the time, and never are you going to set it back or shut it down because the building's unoccupied. So that's you need to remember those exceptions. Capability to maintain zone temps down to 55 degrees or up to 85. So you need to be able to go down to 55 and up to 85. 7 different daily schedules. Retain the program for at least 10 hours if you lose power, and a manual override capability, or occupancy sensors. And in your bigger buildings, of course, this is going to be part of your building management system that's also doing your lighting and everything else. Becky, are we going to be ready to break it right at noon?
Yeah.
Okay. Our dampers. This is something that you're going to get a little bit of pushback, but we really need to specify on the plans or in the specs the damper leakage. There's a difference in cost between a cheap damper and a damper that has been tested and meets this AMCA 500 test on damper leakage. So this is a legitimate question to ask on a plan. It's a legitimate item that should be on the plans for the design professionals, and it's something that those that are installing the systems need to ask the question or ensure that that has been addressed, because damper leakage is important.
It'll screw up your blower door test anyways if you use a cheap one.
Well, it may or may not affect your blower door test, but
Oh,
It does.
Well, depending on where the damper is. If it's an outside air damper, it definitely will affect it. I'm gonna stir the pot a little bit. I haven't found a little cheap 4-inch dryer damper or bath fan damper that anybody's tested. And you have a 500 unit apartment building with 1,500 of those things on the building. How much leakage do we have through those cheap dampers that are probably leaking 5 times that?
Nothing after the bird builds its nest.
Yep. And the little plastic things break off. Yeah. I'll leave it at that.
We're
Ah.
testing though, Brent, we're usually testing at negative pressure, which is sucking them closed.
Yeah.
So it doesn't come into play as much.
Exactly. When you test negative pressure, it does tend to pull them closed. But, you know, there are actually, as I did a little bit of research on it, you can buy some pretty nice inline backdraft dampers that have gaskets and everything on them. And you could actually put that out in the wall with just your cheap one on the outside to keep the birds out or whatever if you wanted to. But and then there's some discussion in the code on the configuration of those dampers. And you know, one of the big things on these is we fail to recognize that when we get a taller building, we have a stack effect or stack action on that building that really promotes air leakage. I mean, it's noticeable. My wife, every winter, when it gets cold and we start heating our house, she has to relearn how to close the garage door. Seriously, I have a 2-story house, and she says I'm nuts. But soon as we go from cooling to heating, if you just give the garage door the little push, it doesn't close tight. Because why? Because with the door open, up through my 2-story house, we're getting some air leakage by stack action that tends to pull the garage door open. And what's it doing? It's pulling air out of my garage, correct? So when we have dampers that we're closing on a 18-story building on a rooftop unit, think of the pressure in the wintertime from stack action against the blades on those dampers. So if they're a leaky damper, we have a lot of air when the building might be unoccupied, simply because the building is heated. We need to be aware that some of these dampers are configured to go to open or closed, depending on the operation of the fire control system or smoke control systems. And also the exceptions that we can use gravity dampers in buildings less than 3 stories, and also for flows less than 300 CFM. We'll do one more slide, and then we'll take our break for lunch. If you have a large building, I hope it doesn't do too much of that. If you have a large building, it has to have the capability to be broken down into zones of not greater than 25,000 square feet. The purpose being, if someone comes in and goes to their office to work on the weekend, we want them to be able to take a smaller piece of the building to unoccupied and heat it or cooled, rather than take 200,000 square feet of building into occupied mode. So it's simply a restriction on, you know, we got to break it up into zones. 25,000 feet is still a pretty big space, isn't it? So that we have a little bit of control on that unoccupied, occupied capability that we have to have in those buildings. Any questions before we break for lunch? Okay, let's take 10 minutes. Restrooms are right here. Get your lunch, get back to your seat so that we can get started about 10 minutes after the hour.
Okay, thank you. Welcome back to the Utah Energy Code Lunch and Learn on mechanical requirements for energy code and today's discussions on the commercial code. Again, my name's Becky Robbins, and we offer these trainings on a monthly basis usually. In the summer, we tend to not offer them as much, and around the holidays, but last month, December 5th, we had a training on reducing air leakage in multifamily projects, and that was a full-day training where we were in a classroom in the morning, and we were actually at Garbett Homes townhomes in the afternoon, and we actually got to see what they're doing to reduce air leakage. As many of you know, that is the biggest weakness with multifamily units, is reducing air leakage. So we try to find what are the topics that are important to you and to offer those so that we can help you. So we're always looking for suggestions. Please utilize our website and keep an eye on it for our next training. And what we'll have our lunch and learns through the spring, and then we'll have a full day residential training on insulation and building envelope, and then we'll have a full day commercial training on some of the issues, concerns that are out there when it comes to commercial HVAC. And so that will be with national building science experts. So Brent will be supported by those who are working around the country and will bring real-world examples of how builders, developers, contractors are meeting energy code. So just want to give that plug so that everybody stays tuned to what we'll be doing, because we've got a lot of great training coming up this spring. So I will turn the time now over to Jim Monsen. He's a representative for the business programs for both Dominion Energy and Rocky Mountain Power, and he will provide just a brief overview of the incentives and rebates available. Thanks.
She said brief because she's afraid I'm going to go really long. Just to kind of give you guys an understanding of what we do. So she said I represent both the Rocky Mountain Power Watt Smart Business Program and the Dominion Energy Thermwise Business Program. So I'm actually an employee of Nexent. And Nexent is a worldwide energy consultation company with multiple divisions. One of the divisions is utility services. So here across the United States, we have lots of contracts with different utilities to administer their energy efficiency programs. So here locally, we have an office, and we represent the Watt Smart Business and Thermwise Business programs for the utilities. So when you call Watt Smart Business, it's going to ring through to us. If you call Thermwise, it's going to ring through to us. We really like that because it gives us the ability to help you on both sides of the program. You don't have to try to chase down multiple people. My role is an outreach coordinator. I work with contractors, distributors, mainly to educate and help them answer questions. Will this qualify? What would we have to do to qualify? What's new? What's not new? Those kind of things. Scott Dwyer, a lot of you know Scott Dwyer in our office. He's also an outreach coordinator, but his background is more focused with the engineers and architects, so that's kind of where his focus is. So I've left my card here. If you have any questions, I'm your resource with the utility incentive programs. So just for instance, I brought this one because we don't have the official paper yet, but this is the updated, all the rebates that are available through Dominion's Thermwise Business this year. Just to make you aware of one quick one that we've added this year, there is now a rebate for direct fired unit heaters. If you have one that pulls 100% outside air to the space without existing destratification, we're paying $6 per kBTU for those units. That started January 1st. So you might not be aware of that. We also increased the amount we pay for boiler tune-ups. There have been some changes. If you got this sheet, you'll notice on gas furnaces that the least efficient one that we paid in rebates for last year is no longer, there's no longer rebates available for it. So I'm a good resource for you on all of those kind of things. The only other one that I really want to touch on that we're seeing really take off here locally is we came up with an advanced rooftop control incentive for retrofits on rooftop units. And if you do it, it's fairly, there's products out now that are doing this that you can add these, and we're seeing our rebate on the Dominion side and our incentive on the Rocky Mountain Power side pay for somewhere between 75 to 85% of the upgrade cost to the customer. So you add CO2 controls to your economizer, you add a VFD to the blower, a couple other little things, and they can get this incentive. So we're seeing a lot of customers really see some really good energy savings on retrofits on existing rooftop units. If you have questions on that, go ahead and reach out to me. Along with that, on the Dominion side, if you add CO2 controls to an economizer, it's a $400 rebate. So you can put those two together, and we're seeing it really cover a big part of the upgrade. And the wheels turn slowly with the utilities and the commissions. We have some updates coming on this where there will be partial incentives if you got on a rooftop that already had a VFD, but you do the rest of it. We're going to have some incentives for that, but that'll probably be March-ish before that comes out. So we want to encourage all of you. We've got our upcoming annual event's going to be coming up the end of February. We'll be sending out invites to that. We're going to have a special section in there dealing with ARC, as well as the updates and changes to the program. So we'd encourage any of you that have time or interested to come to that. Any questions for me on the utility, on the incentives or rebates, what's out there or any of that? I didn't figure there would be, so we'll give it back to Brent.
Thank you. You know, that's kind of, how do you beat that? You get paid money almost, in some cases, almost 75% or more of the cost to save energy over the life of the building, or the life of that piece of equipment. It was kind of nice when I put in my tankless water heater. I got a $350 rebate back for putting in that water heater that I love, that makes water more efficiently and everything else, and really brought the cost down to not that far away from what a standard water heater would have been. So take advantage of some of those things. They're really great incentives. They're always, so you understand that they're always based on where the code is. You have to go beyond the current code, or you have to update a current building to become closer to the code or meet the code requirement. So you don't get rebates for simply complying with the existing code when you build a new building. Any other questions or comments before we try to wrap up in the next 50 minutes, 45 minutes? Okay, snow melt. For those of you, and this is both commercial and residential, if you put in snow melt systems, or if you design in a snow melt system, that snow melt system has to have a control. I'm going to jump to the next slide so it quits flickering at us. And kind of weird, isn't it? Without looking at it, the snow melt system has to measure ambient air temperature, slab temperature, and if there's moisture on the slab, simply because we don't want to be heating a driveway that doesn't have moisture on it, or if the conditions are warm enough that it's not going to hold ice or snow. So if you have a fairly warm driveway and it starts snowing, it's not going to turn on until the slab temperature cools down enough to turn the system on. And it's simply to save a whole bunch of wasted energy. When I first started doing energy code trainings, I had a number of code officials from Summit and Wasatch County saying, this is ridiculous. We want us to do all this, make all this effort to make the envelope better, and we're having people putting in 3 million BTU boilers to melt snow on a 200-foot long driveway. Well, if they're going to do it, that system only should run when they actually need it. So we do have some controls there. Same thing goes with any type of heat trace or any other freeze protection or snow melting you might do. You have to have automatic controls so that when you hit 40 degrees or higher, that it shuts off, so that we're not running those types of heating systems when they're not needed. Economizer, briefly, I'm going to touch on this here and again a little bit later. I know you're not going to raise your hand, How many don't understand how an economizer works? Okay, good. We've heard talk already about economizers and stuff. What an economizer is, basically, we have this room with a lot of people in it. We're creating heat. What if we had a bunch of computers in here, a bunch of lights, we're generating a lot of internal heat within a building. But it's cool outside. Why would we turn on an air conditioner to cool down the space when we can just bring in some outside air and use free cooling from outside air by just bringing in some outside air automatically? And that's what an economizer, a little bit of a simplification, but that's basically what an economizer does. So we have a rooftop unit here that normally this damper might be closed almost all the way. It might just, this is a damper that allows outside air in, or it might be, hopefully it's preset at your minimum ventilation, bringing in just a little bit of air to maintain air quality. And our return air is coming from inside the unit, up through the unit, being cooled or heated, and then going out through the duct system. In economizer mode, what happens is we'll close down this damper a little bit so we don't draw so much return air from inside the space, and we draw that portion from outside. There's a lot more to it. We don't want to bring in 0 degree air and blow it out of the registers because it's going to be terribly uncomfortable. But that's basically how it works. When the conditions are right, we draw in some outside air and use it for free cooling. If you're in a humid climate, you don't want to do that because you're bringing in all this moisture that you're trying to remove. That's what an economizer does. Jim could probably go on and on and on about how many economizers are not operating correctly. Is that right? Yes. And so the code now requires that new economizers, and there's some exceptions and stuff, include fault detections and diagnostics, they call it FDD, on their systems so that you're able to visually see the operation of the system, and it looks at outside air supply and return temperatures. So that is a code requirement if we're looking at economizers. And I believe there's a trigger on what size of unit you need this fault detection system built within there. And here's just an example of a system, and it gives you a little readout of where the system's at and indicates if free cooling is available, if the economizer is enabled, if the compressor is enabled. Because you might be doing both. You might bring in some outside air and do some refrigerated cooling if the heat's enabled, and kind of gives you a bird's eye view of what's going on. And they also must be capable of putting in manual mode so that you can test them. We'll talk a little bit more, time allowing, about economizers when we get a little further on. Hot water boiler outdoor temp reset. Simply, if you're using hot water heating, a boiler for hot water heating, you need a control that senses outside temperature. If it's 45 or 50 outside and you need just a little bit of heat, there's no reason to heat the water in your boiler to 180 degrees. You can heat it to a lower temperature and do a better job of heating your space and more efficiently. Demand controlled ventilation. This kind of ties in with what we were talking about here a minute ago. And some of you have heard this. I'll use the example again. My neighbor Sue, 2 doors down from me, plays the organ in the LDS church in my neighborhood. And she goes over during the week to practice on the organ. And she goes in that chapel that has an occupant load, maximum load of 300 people. Do we need the ventilation air when Sue's the only person in there practicing the organ, do we need the same amount of ventilation air as we do when it's completely full of people, 300 people? No, we don't, do we? But that's how systems have been designed forever. You design it for the occupancy. So 300 people, whether it's 15 CFM per person or 7.5, whichever standard you might be using, times 300 is a lot of outside air. She comes into practice, you don't expect her to practice in a cold building, so she hits the thing and warms up, you know, the chapel while she goes and practices the organ. It makes absolutely no sense, does it? So, as Jim was talking about, CO2 sensors, demand-controlled ventilation is basically, we're not going to count people as they come through the door. We're going to measure the carbon dioxide that they breathe out into the space, and then we'll modulate the ventilation air based on the carbon dioxide that we create in the space. We're creating a whole lot more, and this room itself meets the definition, and this room should have demand-controlled ventilation on it. Because why? We have an average occupant load greater than 25 people per 1,000 square feet. This probably isn't a 1,000 square foot room. And we have 50-something people in here. And our system design, I'm sure, is over 3,000 CFM. So this is a room that should have, in the VAV system, occupancy sensors based on CO2 sensors that modulates fresh air based on, you guys all decided you wanted to breathe when you came to class today. We have, now you need to remember when we're talking about these things that we have requirements that some of us are really familiar with in the mechanical code, the IMC, and then these requirements build on top of that. You know, Don and others in Salt Lake City and in the state have been instrumental in improving the parking garage ventilation systems. And we've worked with other people across the country in doing that and trying to eliminate, I mean, the mechanical code used to have an occupancy sensor. If you sense motion, you turn on the ventilation system. Well, why should we do that? Let's turn it on if we have carbon monoxide or nitrous dioxides from the diesels. And so we have that in the code now. Well, the energy code's going a little bit further and saying, we need to be able to modulate those systems. So if we hit that trigger to where we've sensed that we have enough carbon dioxide that we need to turn the system on, we don't want it running full blast if 50% will take care of it. So it's a similar type concept. Our parking systems either stage fans or modulate fans so that you can draw less than 50% of the design capacity, or intermittently operate fans at less than 20% of the occupied time. Anyway, it gives us some options there so that we don't go full on every time we need some exhaust in that parking garage. Any questions? Okay, the next one we're going to talk about a little bit, and I know some of you know exactly what these are and how they work and everything. However, I can guarantee you that there's people in here that would like a little bit more information. Are you smiling at me, Kathy?
All the time.
All the time. On energy recovery or heat recovery ventilators. We've already talked quite a bit about how we need to bring fresh air into a building for obvious reasons. We breathe and everything else in the building. So we need some fresh air to maintain air quality. But when we do that, we bring in outside air, and if it's 10 degrees outside, that air will have to be heated or cooled depending on what we're doing in the building, correct? I mean, it's just the fact. We throw 500 CFM away, we bring 500 CFM back in to replace it, whether it leaks in or we draw it in with a piece of HVAC equipment. we have to heat the air. And we've thrown away 500 CFM of heated or cooled air. We've thrown some energy away, right? So what a heat recovery ventilator is an exhaust and makeup air fan, two fans combined in a single system, and basically recovers the heat or the energy from the air that we're throwing away and uses it to partially heat or cool the outside air that we brought in. So we're just, exactly as it says, we're recovering some of the heat or energy. The difference between the two is on the energy recovery ventilator, if it's moist outside, the moisture in the air is absorbed in the heat exchanger and sent back out. We don't bring the moisture in to the space. That's not our concern here, but we have a concern with moisture because we don't want to throw all of our moisture away that we just spent money to add to the house. So initially, when these came out, energy recovery ventilators were only thought of as necessary in humid climates. More and more, we're using them in our dry climates simply to conserve the humidity that we add to our house. So how it works real quick is we exhaust some air from the house and throw it away. We bring in fresh air from outside and we temper it, add some of that heat back in. It doesn't get 100%, but it gets between 50 and 80% of that heat. And it's a real savings, especially if you have a huge ventilation requirement. And in fact, the code has places in it that says if you have large ventilation requirements, you need to use this technology to recover some of that heat to be more efficient. Don?
Well, what is the trigger point to require that in the first place?
I think I have it on the next slide, what the trigger is. Any questions on this? Bill?
Would you just address the difference between this and makeup air for, say, kitchen?
For like a kitchen?
Yeah, even like on residential matters. I'm having people call me and say, I have to put makeup air in for my kitchen hood because it's 1,000 CFM, and this is what they want. And I said, you can't do that.
Yeah, okay. The question is, and I've heard this too, the question is if we have a large exhaust requirement in a building. Now, the case Bill brought up was a residential home that has 1,000 CFM exhaust fan in the kitchen. But the same thing occurs in our commercial buildings all the time, whether it's a break room or whether we have a commercial kitchen or we just have a lot of exhaust because of the processes. If we exhaust a lot of air, we have to provide replacement. You can, I mean, how many have gone to a restaurant and you can't open the door? The makeup air is not, something's not balanced right. They're exhausting more air than they're replacing, and so the building is trying to leak all that air into the building. The residential code says that if you have an exhaust fan on your kitchen hood that's more than 400 CFM, you're more than you can leak through the building, so you have to provide some makeup air. You have to find some air to replace it. And so you have to bring in some air from some source. Don't confuse that this isn't a makeup air unit. This is a balanced ventilation system. It's exhausting 150 CFM, it's replacing 150 CFM. So it doesn't solve the makeup problem. Now we get in big buildings and we can, and we'll talk about that here in a minute, we can and we should be considering our ventilation air that we're bringing in the building and using it as makeup air in some cases. But there's a distinction between there. This maintains air quality, but it doesn't add extra air to your space. Everybody with me? That's an important idea because I've heard that 30 or 40 times that, well, I'm putting in an HRV or an ERV, so I've got makeup air for my kitchen. No, you don't. And these are typically, if you're putting these in for ventilation in a home, they're maybe 100 CFM. You know, they could be less, they could be a little bit more. I put them in homes, you know, I put them in my previous home, and I think I put in 2 of them, they were like 100 CFM each or 120 CFM each, and I ducted them into my bathrooms and stuff like that and used them for my bathroom exhaust. But they are not makeup air units. Good question, Bill. And I forgot to put in the slides again. We build a, while I was at the county, they put one of those sprung buildings across the pool out at the Olympic Oval in Kearns, one of the big sprung buildings over a big pool, and put bleachers and everything in so the high school could use it. And they controlled the moisture in that space with ERV and outside air mixing. And you walked in that pool, you didn't sense any sticky humidity, you didn't have the smells or anything. It was much more effective than any of those really expensive dehumidification systems and everything else, and cost pennies compared to what those other systems cost to operate. So they're very effective. And well, there's an answer to your question. Oh, Don just left. There's a table, and I didn't put it in this, but it's 403.27.102 on when these apply. And there's also a lot of places that you cannot put them. You cannot put heat recovery on a grease duct. You'd plug it up in about 3 seconds of operation. You can't use them in certain laboratories. You know, there's places that you cannot use them, but if you have a high ventilation requirement that's just basically environmental air that you're exhausting, there are triggers to when you have to put these systems in, and you must put these systems in. And here's some of the things that where you don't use them, and I'm not going to read through that whole list. You can look through them as you have questions.
But on your, even on your commercial residential, your townhomes, your stacked units and stuff, it's your airflow, air leakage that's going to require these to start coming in too, to get that moisture vapor out. Otherwise, your window's going to have all the fun water condensing on them all winter.
Yeah. You're exactly right, and I probably ought to, as we've talked a little bit about multifamily and stuff like that. When is an apartment building a commercial energy code building versus a residential energy code building? More than 3 stories. 3 stories and less on a residential, on an apartment building, R2, 3, or 4, anything but motels, hotels. 3 stories and less, we follow the residential requirements. Once you hit 4 stories, whether it's just 4 stories, then the whole building complies with these requirements. And I think what you're alluding to is we get these buildings tighter. We need to be doing something, in some cases, to remove the moisture because we're trapping all this moisture inside. So maybe we do need the heat recovery ventilator because we have excess moisture.
You got to have some ventilation at that point.
Yeah, exactly, and we do. And that's the whole reason that we have triggers in the residential energy code that says when you get so tight you need to have whole house ventilation. We need to get away from, and I know I've heard it a million times, we're just building homes too tight. Can you build a home too tight?
No.
These guys I know will say no. And I agree. You can't build a home too tight. What you need to do is build the home as tight as you can, or the building as tight as you can, and then properly ventilate it.
Build it tight, ventilate it right.
Yeah, build it tight and ventilate it right. Ventilation, by definition, is the introduction of outside air by a controlled means. Infiltration is an uncontrolled means. So we say, well, we need to have it a little bit looser so that we can get enough air in there to maintain air quality. But then when the wind's blowing, we're getting way more than we want. Comfort level's gone. The efficiency is gone, everything, it's just not the wise way to build it. So let's talk a little bit about commercial kitchen hoods. This is new to the 15 code. Replacement air introduced directly into the exhaust hood cavity shall not be more than 10% of the hood exhaust flow rate. Now the mechanical contractors in here with commercial experience have seen this and maybe even put in systems where in an attempt to not have to heat your makeup air in your kitchen, there's been short circuit hoods or internally compensating hoods where we blow a certain amount of the makeup air inside the hood itself so it's discharged within the hood cavity. When it really gets down to it and they really study it, when you do that, what you end up having to do is provide a whole bunch more makeup air outside the hood to get it to work, or increase the CFM on your exhaust, and they don't work. And so what this is saying is, if you're doing that, you can't put more than 10% of your air within the hood. So there's a guy out there that just loves to get jobs by kind of working around the code and introducing all the air coming down right behind the hood and playing some games with it. But it doesn't work, and it actually leads to more energy waste rather than less. Conditioned supply air delivered to any space shall not exceed the greater of the following: the ventilation rate required for space heating or cooling, hood exhaust minus available transfer air from adjacent spaces where it's considered part of the outdoor ventilation air. Really what this is saying is, without trying to dissect that paragraph, we have a building that's designed correctly, that has ventilation air being brought into the building. We have a building that's functioning really well. It has quite a bit of ventilation air coming in because it's a big building. And we put in a kitchen hood, and what do? Well, we're putting in a 4,000 CFM hood, so we're going to put in a 4,000 CFM makeup air unit and not consider the rest of the building. Let me take this a little step further so you understand what I'm talking about. And I've shared this experience before simply because it perfectly points to the problem we're talking about. Back in the early 90s, I was called out by an associate, a friend of mine that was a stainless steel guy that did grease ducts. And he said, "Brent, I got a real good job for you. It's a grocery store. I just put in 40 foot of hood. It's an engineered job. The makeup air unit is spec'd. It's a nice Resner unit that has variable frequency drives on it. It has pressure differential controls." So this was a makeup air system that would modulate based on how much air we're exhausting out of the building. If you only had one hood on and you only were exhausting half the air, it would only make up half the air. So I bid the job, got the job, completed the job, went out to do the startup, going through the manufacturer's startup procedures, did everything, and I couldn't get the unit to fire. It wouldn't fire. And so I traced it down, and the pressure differential control that measured pressure outside and pressure inside the building was measuring what? There wasn't a pressure differential requiring makeup air because they had 12 rooftop units or 10 rooftop units on the building that had ventilation air all being supplied to the space sufficient to meet the makeup air requirements created by the hood. So bottom line was they did not need the makeup air unit because they were making up enough air with the building the way it was designed. And rather than the barometric relief on the rooftop units opening up and leaving the excess pressure, relieving that excess pressure, the fans exhausted it out when the hoods were running. Does that make sense? We need to look at the whole picture. And this code change is saying you got to look at the whole building and not just say, I'm putting in a 4,000 or 6,000 CFM exhaust fan, I'm going to add that size of makeup air unit. Because some of it or all of it might be supplied by the building already if you look at the whole building. Additionally, there's some new requirements in there. I read a couple of studies when I first started studying the 15 code and this change. And there's these firms that go out and they study buildings and they look at the energy use intensity, the EUI for that building. And the typical, this study talked about the typical building they were testing had an EUI of 90 to 100,000 BTUs per square foot per year, and the commercial kitchens in those buildings had a EUI of 10 times what the rest of the building has. Commercial kitchens are energy hogs. They use huge amounts of energy, not just in cooking, but because we are running air straight through them. We're exhausting it out and providing 100% makeup air that we have to heat or cool as we bring it in. And so, what the code is trying to do is prevent excessive exhaust and makeup. And the first thing is if you have a hood that your design is greater than 5,000 CFM, it has to be a factory-built hood. We know from experience that factory-built hoods capture better, capture at lower CFM, and so that's the first trigger. It has to be a listed hood in accordance with UL 710 and has to have a maximum exhaust rate that matches what's specified in the table, and I didn't put it in simply because of time. And not less than 50% of all the replacement air transfer, all replacement transfer air, I got two airs in there, that would otherwise be exhausted. So what it's saying is not less than 50% of what we're using for makeup air needs to be air that we'd already be getting rid of, which is exactly what I was talking about in that case. We're bringing in outside air and throwing away other air. What this is saying is you either need to do that or you need to put on a demand-controlled kitchen ventilation system on not less than 75% of the exhaust air. So what this is basically saying is we have demand-controlled ventilation that measures carbon dioxide. We have kitchen systems that use optics and heat and all those things to actually modulate the exhaust on the hood, so that if we have the hood on, and what are we doing? I mean, you guys work on restaurants, I'm sure. You go in first thing in the morning, and what are they doing? They're starting their soups and maybe some of those things, and you have a hood full bore. Pretty wasteful. Until we are creating the smoke and all that stuff, we don't need it running at full speed. So that's what this thing is this requirement is looking for, that we either look at the building and see if, hey, we have at least 50% of our air that we need for makeup we're already providing in the building. It's already being exhausted someplace. So we'll use it for our makeup air, or we'll put this demand-controlled kitchen ventilation control on it. New concept. I had to do a little bit of reading on it because I never installed one. If you're working on those, spend a little time in the code and read up on those. We probably will do a class where we go in a little more detail, like an all-day class on mechanical systems, and we can go in a little more detail on that. Duct and plenum insulation and sealing. This is still pretty much the same thing that's been in the code all along. However, I wanted to make sure you're aware that with the 2015 code, in all of our climate zones here except St. George in Utah, if we have duct in an attic on a commercial building, it needs to be R12. And yeah, I guess that means a 4-story apartment building.
Why would that be different between commercial and residential in the first place? I mean,
Because
the heat loss is the same.
commercials finally realized that R8 is a ridiculously low insulation on a duct that's in a 150-degree environment. I mean, it's completely stupid. I mean, we were having a discussion with this gentleman here during the break. It's crazy. What's the very lowest envelope insulation we might see in a building in climate zone 5? Like R19 in a wall or something like that, R20 in a wall?
It's supposed to be R20, but you can get a model of that down to R19.
Yeah. But then what do we have between an air conditioning duct that has 55-degree air inside, and we have a 150-degree attic environment, and we only have R8 stopping the heat transfer? There's something wrong with this picture. The number one thing is this doesn't belong in the attic, in my opinion. We need to everything we can. And in fact, you're going to see steps in the next 2 code cycles that really move away from ducts in attics or burying them in insulation and things like that, because it's just...
What about getting away from unconditioned attics? Did you ever talk about
We're doing unconditioned attics too, or conditioned attics. Yeah, there's lots of things that, I mean, that's... We have this mindset that we can't do a drop, we have to get that duct out of the way when we can do some things to get it inside and we don't have that huge heat gain.
It looks like it's in conditioned space. Do the insulators?
Huh?
This looks like it's in conditioned space.
Yeah, this one's in conditioned space. Yeah. Sealing. The 15 code requires even the longitudinal seams to be sealed. Actually, the 18 code goes away from that if it's low pressure duct. However, if you're thinking, oh, that's great in residential, we're not going to adopt the 2018 residential codes, so you don't get the benefit of that. But duct sealing includes those longitudinal seams. And that's a snap lock, and so it would include that. It doesn't require it if it's Pittsburgh. If you have high pressure duct systems, we have requirements in there, and those of us that have done it know that when we do in the higher pressure systems, you really have to seal them. If you don't seal them, you're going to have a complaint from the customers because it's going to be whistling like crazy up in the ceiling plenum. I'm going to kind of move through these so that we can get close to the end in the 7 minutes. For the design professionals that might be here, for those that are reviewing plans and bidding plans, those of you involved in it, we have tables in the IECC that define how much insulation you need on piping. This is whether it's heating or cooling or service water heating. Based on the fluid operating temperature, we have tables that show how much insulation we need. I see specifications all the time that are just boilerplate that have never been updated, that they don't have the correct insulation in there for the piping. And in fact, in the commercial code, all your hot water piping needs to be insulated. Every bit of it. With some exceptions. You don't have to insulate valves and unions and stuff like that. They're
Question, Brad?
yes, please.
So does that also, I assume that also applies to recirculated hot water?
If you have recirculated hot water in a home,
Domestic hot water?
a domestic system, that loop needs to be insulated. Absolutely.
Unless it's demand.
Huh?
Unless it's demand. That's a little hidden thing.
Yeah.
Which is
Yeah.
why.
Yeah, unless it's demand. You're right. We have, and I get some, I've probably had a half a dozen calls this past year or so on this one. The code restricts you from, on a new system, from building a crappy duct system and making up for it by going with higher fan horsepower on your Hvac fan. It has tables and everything that gives you direction on how much fan horsepower you can throw at a system, and actually gives you some adjustments you need to make, like if you put better filters in and stuff like that, you can make some adjustments. And we don't have time to go through all these. But the thing that I'm coming up with is someone's installing a replacement rooftop unit and the code official is saying, you can't put the extra fan horsepower on that system. You're going to need to use the lower horsepower according to the table, which would mean they have to tear out the whole duct system because the system's not going to work. We go to the existing building code and we look at it, and really, code officials, we need to use this and understand the intent of the code and not beat someone up, because if Mr. Thompson over here is replacing a unit, his customer is not going to say, oh yeah, I'm more than willing to tear my building apart so I can change the duct system so you can put in a compliant system. The code in the existing building doesn't require you to change a bunch of other stuff to comply with the code.
I don't want them to beat up anybody, of course, but that aero barrier you can use to seal ductwork.
You can use it to seal ductwork. What I'm talking about is ductwork that has bands and stuff like that, where you need extra fan horsepower to get the air through it.
It won't fix the
It doesn't. That doesn't. So, so think about it. You know, because someone does a TI doesn't mean you can tell them, oh, you're doing an interior TI, I want you to change the rooftop unit. Or as this gentleman over here we talked about, really, I don't think the code says, well, you're doing a TI, now you have to put an economizer on your existing unit. I really don't think it goes there. Any heating outside, radiant heating, driving ranges, dining areas or something, has to be on either occupancy sensors or timers so that it doesn't get left on and just runs and runs and runs. We have refrigeration equipment now that has some requirements there. You're going to have to make the decision, code officials, when it's an existing building and they want to bring equipment over from another space that's used that's not going to meet it. Same thing with walk-in boxes and stuff like that. I've had a case where a code official called me and they were on a budget trying to open this little place, and they had brought a used walk-in cooler in that didn't qualify, and they had a discussion. The guy says, well, I'll change out all the lights and put LED on everything. And he said, okay. It's horse trading. It's not actually energy modeling, but it's horse trading. It's not going to be as efficient as you might think or we might want, but we're going to do something that we didn't have to do. So I don't have a problem with us doing that. Same thing, we have some requirements for these walk-in boxes, and it's very common for these to be relocated, so you need to consider the same thing there. Economizers, we've really talked about them a lot. I got a few slides that we're going to skip through here, but basically anything over 54,000 BTUs or 5 tons or larger needs to have an economizer. And then we have some stuff on chilled water that we're simply not going to have time to talk about. Using a cooling tower without the chiller, what I'm saying is taking cooling tower water and running it through a separate coil for indirect evap cooling is economizing, and so that qualifies. There are some exceptions. You don't need to do the economizer thing if there's operations less than 20 hours a week, or grocery stores where in humid locations where it might affect the refrigeration. I'm going to skip through. When you get bigger buildings, you can't just rely on a barometric damper and relieving the air on economizer. You might have to have a power exhaust that's removing it. When we get to bigger boilers, more than half a million BTUs, you have to have multi-stage or multiple boilers. You can't have one great big boiler that just turns on and then turns off. We need to stage it in because we don't need all that heat sometimes. You cannot use 3-pipe systems where you use a common return. And if you're using a 2-pipe system that use the same piping and everything for heating and cooling, you need to have a 15-degree changeover temperature, dead bad between it. Our cooling towers, we have some fan horsepower requirements that are either variable speed or 2-speed, and I'm just gonna we already talked about heat recovery for surface water heating. Pools need to have controls, switches that you can readily shut it off. They can't have standing pilots. You have to have controls on your pumps so you don't run the pumps all the time unless it's a 24-hour operation. And the last thing, and I'm just gonna say this, if you have total cooling capacity of 40 tons and 600,000 BTUs of combined service, water heating, and space heating capacity, your system has to be commissioned. That means a commissioning plan in the plans right from the start. Any question on that? I've already talked about documentation. We made it. It's 1 o'clock. Any questions? Thanks so much. Great group. Large number of people here. Appreciate it. Feel free to get a hold of me if you have questions, and especially if you have a suggestion on what you want us to talk about. And we'll see you next time.